Okay, good morning. Welcome to
FunMath number 199.
FunMath number 199. So today we were working on the 2001 AMC8, right?
Yeah.
And it had a problem about a grid. It was a pretty fun problem to work through. It's a neat, this is called coordinate geometry, or it's kind of like coordinate geometry. So they asked a couple of questions, and I'll ask you some questions. So suppose these grids, were all the same in between the dots, the distances, even though I didn't draw it quite perfectly. Suppose those distances were all 1 on this grid, so what they call a 1-inch grid. What would the area of this triangle be if this was a 1-inch grid?
Well, that means this side's 4. And this side's 4 as well. Wait, yeah. So it's the area of a triangle is 1/2 base times height.
So write that out over there. One half base times height. Okay, awesome.
So we've got 1/2 4 times 4. Or 1/2 of 16, which is 8.
Okay, go ahead and write that up. Okay. Now, suppose, as what just was in the problem, suppose now instead we have the exact same picture, but the grid lines are 3 inches apart. How big is this triangle now? So first of all, before you calculate, just guess. How big, what do you think the area of the triangle is now? Quick guess.
It could be 3 times 8.
Could be 3 times 8.
24.
Okay, so let's see.
So since 4 times, this side's 4 times 3, which is 12.
Okay,
So there's this side.
alright.
So it's 1/2 12 times 12. Or 1/2, or just 6
Scoot
times
over
12.
6 times 12, which is
Which is 6, it's 72.
72. Okay, so interesting. So you thought it might multiply the area by 3, but instead it multiplied it by what?
9.
Okay, and why is that?
Well, because this is in square inches,
Okay,
or square feet.
so what does that mean?
Well, we went from the square being 1, 1, 1, 1 to it being 3, 3, 3, 3. And the area went from 1 to 9.
Okay, the area of each box went from 1 to 9, it got multiplied by 9. And where did the 9 come from?
3 squared.
3 squared, okay. So the original box, the original grid I mean, was 1 by 1 and the area was 8 of our triangle. Then when we went to 3 by 3, instead of 1 by 1, we kind of expanded it a little bit.
Yeah.
The area was 72. So now, if I make the grid lines 2 by 2 now, markers running low, 2, 2, 2, 2. Without doing any work now, what's the area of our triangle when the grid lines are 2?
Well, it's 2, 2, 2, 2. So the area is 4.
Okay, so what's the area of our triangle?
It's 8 times 4, which is 32.
8 times 4, which is 32. What if I made the grid lines 10 apart?
It
Your
would,
marker?
it would be 10 times the. No, wait. It would be 100 times. It would be 800.
Right, 800. The area would be multiplied by 100. Okay. What does the perimeter get multiplied by in this case? Even though we haven't calculated the perimeter. When I increase the side length,
It's 40 by 40 right now.
it's 40 by 40, and then whatever this is. It's actually 40 times the square root of 2 on this one. But when I multiply the side lengths by 10, what does the perimeter get multiplied by?
The perimeter gets multiplied by, well, we haven't figured out the perimeter for the other ones.
That's true. That's why I'm asking you the question, to see if you can understand. When I multiply each length by 10, what does the perimeter get multiplied by?
Well, we should find out what it is when it's 1.
Now, without finding out what it is, I don't want you to find out what it is. I want you to just tell me when I stretch out the grid, what does the perimeter get? Well, we already figured out what the area gets multiplied by. The area gets multiplied by the square of whatever we stretched it by. How about the perimeter?
I wonder if the perimeter gets multiplied. How can we need to figure out the hypotenuse here?
No, without figuring out any of the lengths. What do you think? What's your guess as to what the
I think it gets multiplied by 10.
Okay, why?
Because you're just stretching out these.
Right, you're just stretching out the distance in between. So whatever the perimeter was originally, it gets multiplied, in this case, by 10, because that's exactly what you're stretching out. Those bits, right? When you're talking about the area, you're actually stretching out these squares, and they get multiplied by the square. Make sense?
Yeah.
All right. Good job, sweetie. Good, George.